Hey y'all. Alright, so today we're going to be looking at just-in-time sections 1.1 through 1.3. Okay, so we'll start off with 1.1. I'll zoom in so you can see it. Before we actually get to the multiplying and dividing of fractions, I've got a couple notes, just things to kind of, so we're all on the same page terminology-wise. So first off, for multiplication, in this class and pretty much any math class beyond this, you should use either a dot or parentheses. Because we use x as a variable, it's easy to get it mixed up with the cross for multiplication. Okay, so just as a tidbit. Moving into fractions, so any number can be written as a fraction. Okay, it can be something like 1/2. If you've got just a whole number like 3, that can still be written as a fraction. You just stick it over 1 because you're not actually changing anything about the value of 3. That's still 3. Okay, and sometimes you'll need to do that when you're simplifying stuff or needing to combine two things. Okay, so we've got a couple different types of numbers, and these will really come into play later, but I figured it'd be better to just go ahead and introduce the terminology. So there's real numbers, which you might see represented as this script R. Okay, real numbers can have an infinite number of digits. It's really all numbers except for complex numbers. And while we don't necessarily do a whole lot with complex numbers, just know that they exist. Okay. We've also got rational numbers, and you'll see that represented as a Q. And it's any number that can be written as a fraction. Okay. So some whole number over some other whole number. Okay. Integers are all of our whole numbers or counting numbers with 0 and their negatives. Okay, and integers get represented with that z. Okay, and then lastly we have irrational numbers. These are numbers that have an infinite number of digits and can't be written as a fraction. Okay, they just kind of keep going on and on and on. Some examples of this would be pi. Okay, you can, if you were to use a computer program to look and see what pi was mathematically, it would be 3.141592 and then a bunch of other numbers. Okay, E is another mathematical number. It's a similar concept as pi. Because E and pi, because they're rational numbers and there's not a way to write them nicely, we use the letters pi and E. Okay. And then square root of 2 is also an irrational number. Okay. Alright. So there's our numbers. Now we'll get into the actual bulk of 1.1. So multiplying fractions. So when multiplying fractions, you multiply the numerators together. So anytime you've got a fraction, the numerator is, so say we've got a fraction AB. Okay. The numerator is the top number. Denominator is the bottom number. Okay. All right. So when we're multiplying these, we're going to multiply the numerators together and then the denominators together. You just go straight across. Okay. Sometimes it is possible that we can cancel terms before we multiply to make it a little easier. So for example, in this problem, okay, we can rewrite this as, so we can rewrite 12 as 2 times 2 times 3, still over 5. And then we can rewrite that 24 as 2 times 2 times 2 times 3. Okay, and then we can look and see what cancels. Well, we've got a 2 here and a 2 here, that'll cancel. A 2 here and a 2 here, that'll cancel. And the 3 and the 3. Okay. We also could have canceled this 3 with this 3, but we can't do both. Okay, it's a one or either thing. But so we cancel everything, and then we're left with 3 over 5 times 2, which is 10. Okay, and see, that was easier. We could have gotten the same answer if we would have just multiplied and then simplified, but this was a little bit easier. Okay. And when you're doing this, you won't necessarily have to write that out. I just wanted y'all to be able to see what was happening. Okay. Sometimes we can't cancel terms before we multiply, but after we finish multiplying, then our answer can be reduced. So this is one of those cases. So we've got a negative number here times another negative. So our answer will be positive. Okay, because those will cancel out. And we can multiply across, and we go 1 times 3 times 2 is 6. We don't have to write the positive. So 6 over 7 times 8, which is 56. And we leave pi as pi. All right, now, we couldn't cancel anything up here, but we can reduce 6 over 56. If we divide them both by 2, then we get 3 over 28 times pi. Okay. So we divided the 6 by 2 to get 3, and then we divided 56 pi by 2 to get 28 pi. Okay. Now, a big important note here. Okay, make that a little bigger. You can only cancel numbers that are factors of the whole numerator and the whole denominator. Okay, so for example, we've got a 3 here and we've got a 3 here and a 3 here, but there's not a 3 here. Or in other words, there's an addition symbol up here, so we cannot cancel. Okay? Okay, so we cannot cancel. Now, down here, down here we've got a 3 in both of these, so we can factor that 3 out and rewrite it. So we can rewrite this as 3 times 1 plus x squared over 3. Okay. So we took the 3 and then the 3 here, and we pulled them out. So if we were to take this 3 and multiply it by each one of these, it would get us back to here, to what we started with. All right. So we're going backwards a little bit. But we do that, and that allows us to cancel. So we've got 3 times something else, and that will allow us to cancel this 3 with this 3. Okay, leaving us with just 1 plus x squared. But the important thing here is that y'all see the difference between these two problems. Okay, and if you're still confused on this, let me know. Okay. Come to office hours. We can work on that because that's really important. And you may think it's silly now, but later when we're doing things that require a lot of steps, it's very easy, and this is probably one of the most common mistakes we see. Okay, is canceling stuff when we cannot cancel. Okay, so if you still have questions on that, let me know. Okay, otherwise we'll move on to dividing. All right, so multiplying, we went straight across. Dividing is a little more complicated. So to divide, you can think invert and multiply. Or another way to remember this is keep, change, flip. Okay, so we're keeping the numerator the same. So we'll rewrite it. So we'll keep the numerator the same, a over b. Change the sign. So change the division to multiplication. And then flip the bottom fraction, or the denominator, so that becomes d over c instead of c over d. Okay, so the invert and multiply comes from inverting this fraction and then you're multiplying them. Okay, so whichever way you want to remember it, whether you do invert and multiply or keep, change, flip, whichever way you do, great. Okay, use whichever method you need to be successful. But all right, after we do that step, we now have a multiplication problem, and we just multiply across like we normally would. Okay? All right, so that was multiplying and dividing fractions. Now, with multiplying and dividing fractions, we did not need to have a common denominator. It didn't matter what the fractions are. With adding and subtracting fractions, we will have to have a common denominator. Okay? They absolutely must have a common denominator. Now, if we're given two fractions and they have the common denominator, great. It makes it easy. Then we just add the numerators or subtract the numerators depending on what the problem is asking us to do. If they don't have a common denominator, then we have to write them as equivalent fractions that do have a common denominator. Okay, we can do this a couple different ways. The simplest two ways are finding the least common multiple or by multiplying by the opposite denominator. Okay, and we're going to look at both of these now. Okay, we'll do the same problem just so you can see it play out. All right, so if we look at, we've got 2 6 plus 3 8. 6 and 8 are obviously not the same number. So we need to find that common denominator. So we'll do the least common multiple method first. Okay. So with the least common multiple, what we'll do is we'll take our two denominators, so 6 and 8, and we'll list out their multiples. So if I were to look at my multiplication facts for these, that would be my multiple. So for 6, it'd be 6, 12, 18, 24, 30. For 8, it'd be 8, 16, 24, 32, 40. Okay, and what we're looking for when we do this is the least one that they have in common. So in this case, that would be 24. Okay, so now what I do is, so with 6, it's 6 times 1, 2, 3, 4 to give me 24, and with 8, it is 8 times 3. Okay, so I'll take my problem. Okay, I've got 2 6 plus 3 8, and I'll take in the 6 will get multiplied by 4 over 4. Okay, if I have a number over itself, that's just 1. So when I multiply by that, I'm not actually changing the value of that fraction. Okay, we're just rewriting it. So with 3 8, we'd multiply it by 3 over 3. Okay, and then that gives us 8 over 24 plus 9 over 24, which we can then add 8 plus 9 is 17 over 24. Okay, so that's using the least common multiple. And using that method is nice because your numbers are smaller. Okay, so when you're working with the numbers, they're smaller because you found that lowest number. But it's not always the easiest to find that common multiple. So what you can also do is multiply by the opposite denominator. And that will also give you a common denominator. It just might be a larger common denominator. So to do multiplying by the opposite denominator, we'll take, and so we've got 2 6 plus 3 8. So 2 6 will get multiplied by 8 over 8. 3 8 will get multiplied by 6 over 6. Again, 6 over 6, 8 over 8, all we're doing is multiplying by 1. Okay? Now, this gives us 16 over 48 plus 18 over 48. And you can already see what I mean by the numbers being larger. Okay, but it works out the same. So this would equal 16 plus 18 equals 34 over 48. If we were to divide this by 2, so 34 divided by 2 is 17, 48 divided by 2 is 24. That would reduce on down and give us the same answer. Now, something to remember, this reduction step, you have to be able to divide both the numerator and the denominator by the same number. So in this case, we could multiply them both by 2. If that wasn't the case, then it would be in our reduced form. Okay. Now, something to remember, when we are simplifying an expression, our goal is to get it in simplest terms. Okay, so that means in terms of multiple fractions, so whether it has addition of fractions in it or division of fractions or multiplication, our goal is going to be to get all fractions down into one fraction. So we'll combine as much as we can so it's down to one fraction. Okay, so that's just something to remember as we go and we start looking at more complicated equations. Okay, the last section of this video will be 1.3. All right, and so we're looking at parentheses. Parentheses is a way, just a way to group numbers together, or letters. Sometimes we use letters to represent numbers. They can be parentheses like this with the curve, or sometimes we might have more than one parentheses, like we might have parentheses inside of parentheses. So if we're layering, you could also see or use square braces just to keep everything straight. If you get a couple layers of parentheses in there, sometimes it's nice to use that to make it easier to keep track of what goes with what. Now, if you remember back, I don't know when you would have learned this, maybe middle school, maybe, depending on when you started taking, depends on, I guess, where you took your math class. But by order of operations, or PEMDAS, okay, that's that order of things, the order of the way we do things in math. Okay, so we'll do parentheses first, if there are parentheses. Okay, so anytime we're given an equation and they want us to simplify it or to do something to it, our first step is always going to be to simplify parentheses. Now, sometimes this will mean simplifying inside. So if we look at this problem here, inside each of our parentheses, we have two numbers that we can either add or subtract and simplify it. So that'll be our first step. Okay, so in this case, we'll do 5 minus 1 plus a half is 3/2, plus 3 minus 4 is -1, minus 7 minus 1 is 6.5, or 13/2, if I write it like that. For this class, it's really easiest if you leave stuff in terms of an improper fraction. So like the 13/2, as opposed to writing it as a mixed number, or the 6.5. Okay. They're both the same thing. It's just easier to not have that extra number hanging around. All right, so now we can sort of drop our parentheses, so it ends up being 5 minus 3/2 minus 1. And you'll notice what I did there is I started writing a plus because of this plus here, but because the number inside of our parentheses is negative, that's the one that sticks. You can think about it as positive times a negative, then it's going to be a negative. Okay. It's the same thing when the negative's on the outside of the parentheses and we have a positive on the inside. It's just easier to miss it when the negative's on the inside. Okay, so then we've got minus 13/2. And if you simplify that down, so 5 minus 3 halves minus 1 minus 13 halves is going to be equal to negative 4. Okay. Now, sometimes we can't simplify the inside of our parentheses like we did in this step. Okay. The other way we might do it is by distributing. So, distribution, okay, is where we're going to multiply all of the terms inside of the parentheses by the term on the outside. And in this case, we could simplify inside the parentheses, but I'm going to use this to just show you distribution. So the way this works is we take our number on the outside, so that negative 2, and we'll multiply 1 by it, okay? And then we'll multiply 3 by it. Okay, so we get negative 2 times 1 plus negative 2 times 3, and we get negative 2 plus, minus 6, which would give us negative 8. Okay, same thing as if we were to take, and if I would have done negative 2 times 1 plus 3 is 4, that would have also given me negative 8. Okay, something to remember with parentheses. If the outside term is negative, it gets distributed too. Sometimes there won't be a number there for you to see, and it'll just be might look like this. Okay? We don't always write the 1, but it's just generally recognized that there is a 1 there, and so that negative gets distributed to both of these. This is another one of these really common mistakes that is easy to just skip or miss when you're doing several different steps in a problem. So it's really, really key that you remember this. Okay? All right. So that's our sections 1.1 through 1.3. If you've still got questions on it, you can ask during our class period, or you can email me or come to office hours. We'll end this video by doing just a couple of examples, so y'all get to see a couple more examples worked out. Alright, so this first one we're looking at, we need to add and subtract. We've got 4 fractions here, and they've all got a different denominator. So what we'll do is we'll find a common denominator between all 4. Now, the easiest way for me to do this is going to be to I'm going to list the multiples out, and we'll find the least common multiple. You could multiply by the opposite denominators, but if you were to do that, you would have to multiply 6. You'd have to multiply it by 3, 9, and 2. 3 would have to be multiplied by 6, 9, and 2, likewise. So because that would give us some really large numbers, I'm going to just list out the multiples. So we've got 6, 12, 18, 24. Okay, 3, we've got 3, 6, 9, 12, 15, 18. 9, we've got 9, 18, 27, 36. And then 2, we've got 2, 4, 6, 8, 10, all the even numbers, including 18. Yeah, so we'll see. 18 is our least common multiple. So that'll be the one we use. So we'll take 6, and to get to 18, we'll have to multiply it by 3 over 3. So this will be 3 over 3 times 5 over 6 minus the 3 to get to 18, we'll have to multiply by 6 over 6. Plus the 9 to get to 18, we multiply by 2 over 2. Minus, let's move these, shift it, because otherwise I'm going to run out of room. Alright, and then the 2 to get to 18, we multiply it by 9 over 9. Now, I know some of y'all may be looking and thinking, well, wait a minute. These are all just combinations or the other denominators that we had switched around. This won't always be the case. It's kind of just happenstance in this situation. Okay, so you can't always bank on that. All right, so now we'll simplify, and we've got, this becomes 15 over 18 minus 24 over 18 plus 4 over 18 minus 27 over 18. All right, and then if you do 15 minus 24 plus 4 minus 27, that gives you negative 32 over 18, which we can divide both by 2, and that gives us negative 16 over 9. Okay. So, there was a slightly more complicated example with addition and subtraction. All right. Now we've got an example where we're dividing fractions. So, what we'll do is we've got our first fraction, so we'll leave that the same. That'll be xy over x plus y. We'll change this to multiplication. And then our denominator will get flipped or inverted. So that'll be x plus y cubed over x squared y. Now, before I do anything else, I happen to notice I've got an x here and an x squared here. So I can simplify that, and that'll just become an x. I've got a y, that'll cancel. And I've got an x plus y and an x plus y cubed. So I can cancel that, and this becomes an x plus y squared. Okay? And if you have some questions about what happened there, feel free to ask me. Okay? But what we're left with is x plus y squared over x. Okay? Because that all canceled. This canceled, the y canceled, so we were left with just one x and an x plus y squared. Okay? Now, our last example for this video was using our parentheses, and here you'll see the case where we don't necessarily have a number here. That just means there's a 1. So, what we'll do is we'll have this 4xy, and then we'll distribute this minus to both of these terms. So that'll be minus x plus 2xy, because negative times a negative is a positive. And then we'll take our negative 2y here and distribute it to both terms. So we get negative 2xy plus 2y. Now, if we're looking here, we've got a 4xy, a positive 2xy, and a negative 2xy. So if you've got variables that repeat, then you can combine those. So in this case, the positive 2xy and the negative 2xy will cancel. Here, let me do this so y'all can still see it. Sometimes that won't be the case, and we'll just add them all together. In this case, they canceled. So we are left with a 4xy minus x plus 2y. Okay, and that is our simplest form. Okay, all right, so that is this video. If you make sure you, when class starts, this will be Friday, make sure you upload a page of your notes for the lecture check. And then let me know if you have any questions.